Hello friends, welcome to my channel Colors of Infinity. Here I will solve the previous questions of real analysis. Here we have the question from June 2013 section B of marks 3. As it is the question of section B, so only one option is correct. Question is, which of the following series is convergent? To solve the question, firstly let us take option 1, which is summation 1 by root of n plus 1 minus root of n. Let un is equal to 1 by root n plus 1 minus root n. Here un is the nth term of the series. Now to find the convergence of the series, we will apply the comparison test. To apply the comparison test, we will consider another series whose nth term Vn is equal to 1 by root n. Now let's consider limit n approaches to infinity un by Vn, which is equal to limit n approaches to infinity 1 by root n plus 1 minus root n divided by 1 by root n. In the next step, as we take root n as a common factor, therefore we get limit n approaches to infinity 1 by root n into root of 1 plus 1 by n minus 1 whole divided by 1 by root n. Here we can clearly see that the factor root n balance out and we get limit un by Vn as n approaches to infinity is equal to limit n approaches to infinity 1 by root of 1 plus 1 by n minus 1. As n approaches to infinity, therefore 1 by n will approach to 0 as n approaches to infinity. Therefore we get 1 by 1 plus 0 root minus 1, that is 1 by 1 minus 1, that is 1 by 0, which is equal to infinity. Then by comparison test, both series un and vn converge and diverge together. As summation Vn and summation Un both converge and diverge together, therefore we will check the convergence or divergence of the series Vn. Let us consider Vn, which is equal to 1 by root n, that is 1 by n raised to power 1 by 2. Now by p-test, summation 1 by np diverges for p less than and equal to 1. As p is already 1 by 2, we can clearly see that Vn is divergent as p is less than 1. Hence Un will also diverge. Therefore option 1 is wrong. Now consider option 2. Let the summation Un is equal to summation sin n by n squared. Let the nth term of the series is Un. Let us consider mod Un, which is equal to mod sin n by n square. As we know, the range of the sin n function is from minus 1 to 1. Therefore, mod of sin n by n square is less than or equal to 1 by n square. Now consider the series summation 1 by n square. This series converges by p-test as p is equal to 2, which is greater than 1. Therefore, the series on the left will also converge by comparison test. Hence, option 2 is correct. Now, consider option 3, series minus 1 to n log n. As we can see, the minus 1 here, therefore we will apply Leibniz test for alternating series. Now, for alternating series, we will apply Leibniz test, which states that the limit of nth term it should be equal to 0. But when we apply the test here, then the limit of n approaches to infinity is equal to limit of log n approaches to infinity, which is infinity because log n is an increasing function. Hence the series is divergent. Therefore, option 3 is wrong. Now consider option 4, summation log n by n. Let's consider nth term of the series un, which is equal to log n by n. Friends, here we will also apply the same technique of comparison test, which is by considering another series Vn whose nth term Vn is equal to 1 by n. We will take the same limit un by Vn as n approaches to infinity. You can clearly see here then that the n in the denominator balance out and we get limit n approaches to infinity log n. As log n is the increasing function, therefore we get infinity as the limit. Hence by comparison test, if the limit un by vn is equal to infinity, both the series converge or diverge together. Also, the series Vn, which is equal to summation 1 by n, diverges by p-test because p is 1 here. Therefore, our series Un will also diverge. Therefore, option 4 is wrong. Hence, the only correct option is second. Like, subscribe and share the video.